Alright, let's try 11 through 16. In the diagram, the perpendicular bisectors meet at G. Well, let's just pause right there. Perpendicular bisectors. We have to translate that into which triangle center are we talking about? Well, that is the circumcenter. Okay, the circumcenter is the one that is the intersection of perpendicular bisectors. So hopefully you have that memorized by now. So once you realize that we're talking about the circumcenter, then the next stop in your train of thought needs to be, what are these special properties of the circumcenter? Go ahead and say it out loud before I do. Okay, the circumcenter is equidistant from the vertices. So these lines that are shown here in red, if G is the circumcenter, these red lines would be the ones that should be congruent. So all the red lines should be congruent because it should be equidistant from the vertices. So if we know one of the red lines, we should know them all. Do we know one of the red lines? We sure do. One of the red lines is 25. So right there, that means all of the red lines are 25. So I'm just going to go ahead and mark them right now. Okay. Let's see how many questions we can answer. We got perpendicular bisector. Oh yeah, by the way, perpendicular bisectors. So like these dashed blue lines, these are the perpendicular bisectors they're talking about. That means that we know that these blue lines are forming 90-degree angles, like this, okay, and like this. So we have right angles. So if we do need to do the Pythagorean theorem, we can, because these are right angles. We also know that these are bisectors, so that means we're cutting things in half. So these points like D, E, and F, these are all midpoints. So because D is a midpoint, then if this is 20, then this is 20. If this BE is 15, then EC is 15. If AF is 24, then FC is 24. Okay, because of bisectors. Okay, so we've probably found a whole bunch of things. If anything that's missing, I bet we're going to just do the Pythagorean theorem with these right triangles. Let's see what we've got so far. AG. AG is one of the red lines. That is 25. Okay, CF. CF, that is 24. CE. CE was 15. BD. BD was 20. BG. BG was a 25. And AC. AC is 48. Okay, so they didn't ask us anything that would have required us to do the Pythagorean theorem. But you know, they could have. I could have asked you, for example, for the length of DG, maybe. And so you would have had to do x squared plus 20 squared equals 25 squared to get one of these dotted lines. So just don't forget about that. I could easily ask you to find one of these dotted lines, and you would just have to do the Pythagorean theorem of the triangle. So that's number 11 through 16.